When I was a kid, I used to watch these weather reports that used to come on TV, and that person used to tell that Mumbai got 85 millimeter rain, or let's say Chennai got 75 millimeter rain. And I was always wondering, how are they measuring rain using this millimeter? And then later I came to know that they use this instrument or this tool called rain gauge. And what it does is basically it is a container whose opening is of the same size as its base and its sides are straight. So whenever I used to go to a library, I used to take these science experiment books, and they used to describe how can you make one rain gauge on your own. Take any container which has the same opening and the same base, and the side should be straight. But then I thought, can't I take a container which has a smaller opening, but the base is same as that opening and the sides are also straight? Can I take this container and measure the rain? So if I keep these both outside, let's say it is raining, and if I keep these boards outside on the ground, and I want you guys to think, what will happen? Let me just draw this properly. Okay, so let's take, so let's say I have one container which has a smaller opening, and I have kept these both out. It's raining and I've kept these both out. And I wonder now, in which container will water get filled fast? So we know if the water is filled till here, then we need to measure this height, and let's say it is 50 millimeter. Then we say that it has rained 50 millimeter in this place. So my question is, when we have two different containers, will the water level be the same in these both containers, or the water level in this container is more? Just think about this for a second. So now let's try to find the answer for this. And in order to do that, let me just redraw this whole thing again in a different way. Okay, so in order to answer this question, whether this container has more water level or this container has more water level, or are they equal? So in order to answer that, so we can either do it mathematically, which I'm not going to do today, or we can try to just see it using diagrams. So I have just redrawn this whole thing, and what I have drawn is I have just represented this rain in a different way. So let's say that it's raining for just a small amount of time, and that rain, I have represented it as a layer like this. So imagine this whole layer, it is coming down, and if you're standing here, you will feel the rain for some time, and after some time it will stop raining. So it is raining just for a small amount of time. In order to help you visualize, you can think of it like this. So this is the rain, and it is coming down. It's coming down, it's falling down. You are standing here, so as soon as the rain touches you, you feel that, okay, it's raining. It is raining, it is still raining, and now it has stopped. So you can imagine the rain in this way. So if it is raining for a longer time, what I can do is the width of this will be much bigger if it is raining for a longer time. If it is raining for a much longer time, it will be much bigger. But so that's how I'm representing the rain. And one more assumption, and another thing that we have to assume, that these drops, right, they are distributed uniformly. If you take any particular area and if you count the drops, in how many drops are there, so you will feel that we are assuming that the density of those drops, or the number of drops in one particular area, it is the same all throughout. So that is another assumption that we are doing, just to keep things simple. Okay, so let's try to understand this, answer this problem. The raindrops are falling down and it's coming down, it's coming down. Now you can feel that it has started raining. And now also try to observe what will happen when rain hits these containers. So as the rain passes down, as the rain goes down, and once it stops completely, what do you think will be the water level in these two containers? Just think. You can pause the video and try to answer this question. So because the way I have drawn the diagram, it now I don't know if things will be clear, but as you can see, the level of water in these two containers, it will be the same. We can try to visualize this and we can see that as it rains below, this container, it will get filled with this much amount of water, right? Whatever is right above it, so it will get filled with this much amount of water, and this container will get filled with whatever is falling on top of this. Okay, so that is this much, and this container will get filled with the water which is on top of this. So this whole thing will get filled with this whole thing will get filled with this. So you can just visualize that. So it falls down, it comes, and after that it stops raining. So you can see that the level of water, it will be the same in both these containers. So if the water level is this much, if it comes down, so the water level will be the same in both these containers. It is the same in both these containers. And if you, let's say I have a much bigger container. Let's say I have a much bigger container. Let me draw a little bit big. If I have a much bigger container, still this container will get filled with water which is falling on top of that, right? So this will get filled with whatever is on top of that. So again, the water level will be the same. So here we can see that the water level, the height of the water is the same in all three containers. But yes, this will contain less water. This will contain little bit more water because the volume is higher. And this will contain the most amount of water because this has the highest volume. So the volume is different, but we are not interested in volume when we are measuring rain. We are only interested in height. So no matter what the size of the container, the height will be the same. Let's say if this is 50 millimeter, this is also 50 millimeter, this is also 50 millimeter. So you can see that you can say that it has rained 50 millimeter in this area. So you can see the size or the diameter or the opening of this container does not matter. Only thing that matters is the opening area should be equal to the base and the side should be straight. And this is why the size does not matter, because the height of the water will be the same. And now something for you to think about. Now if I change this container with a container of a different shape, let's say this is cylindrical in structure. Let's say I don't use a cylinder, but I will use a cuboid shaped container. Now what do you think will happen now? So this is something that you can think on your own. If you get the answer, please type in the comment section. That's all for today. Thank you for watching.